This is Unit 8 FRQ Part B. I'm just going to do number 1 in this first video. There are 2 separate questions in this free response progress check. So starting with number 1, they give us this lovely graph right here. And so I'm going to keep showing you that graph. On the next page, they tell us what the actual equation is for that graph. It's a piecewise function. It's like 2 parabolas put in one. So I'm going to write it down here so that I can show you on the graph. All right, so that's our piecewise function. Now just to get this up on the screen as well to show you. So 2 minus x squared up until this point right here. So I just want to mark that in the middle. It's a downward parabola, right? Y-intercept of 2. We know it's going to be upside down. Sorry, that was a little fuzzy. So that's this piece right here, and then it cuts off once we get to 1. Then the next one picks up. So this is x minus 2 squared, which means it's a regular parabola that's shifted from the origin over 2 units. So this part would be like just a regular right side up parabola. So they connected them, and they meet up, so there's no weird jumps or anything. But this is the equation that we're working with. So let's see what they ask us first. Letter A just said find the area of R. Okay, so the area of R. Continue to put this up on the screen here. So this is this shaded region right here. We want to put our little slices into this, our little representative rectangles, and the part that you're going to notice is that here our upper function is the first part of the piecewise function. If I were to move over here, our upper function is the second part of the piecewise function. So because it's defined by 2 different pieces, our integral would have to be set up in 2 different pieces. All right, so our setup, our integral. First piece goes from 0 to 1, and you integrate this first piece. So from 0 to 1, it's this part, 2 minus x squared. And area is just upper minus lower, so this is the upper function. The x-axis is the lower function, so that's just a 0. Plus, and then the second piece, we integrate from 1 to 2, and it is this part right here, x minus 2 squared. And then again, just minus 0. So that gives us this second portion of it right here. So this is a non-calculator question, which means we are integrating this by hand. Sometimes they'll tell you to set up but do not evaluate. They don't say that here. They just tell you to set, or they tell you to evaluate, since they don't tell you to set up but not evaluate. So we're going to integrate this by hand. Antiderivative of 2 would be a 2x minus antiderivative of x squared is 1/3 x cubed. We take that. We integrate it from 0 to 1. Plus, and then we move on to the next piece. This x minus 2 squared, the x minus 2, you can kind of just treat it as its own variable. So just like this, the antiderivative here is here, the antiderivative of this is this, and we evaluate that from 1 to 2. All right, so here the 1 gets plugged in first. We get 2 minus 1/3, and then minus 0 is just 0 minus 0. Plus, next piece we plug in the 2 first, so we have 1/3 times 0 cubed, minus, and then we plug in the 1. We have 1/3 times 1 minus 2, so negative 1 cubed. All right, so combine those all up. Let's see, this is just 0, this is just 0. This gives me a negative, like in the parentheses, I have a negative 1/3, and then this changes to plus. So what actually ends up happening is these 2 pieces cancel each other out, and I just end up with 2. Just a nice, neat 2. All right, letter B. Letter B says region R is the base of a solid. For each solid, the cross-section perpendicular to the x-axis is a square. Right, but do not evaluate, so that's what I mentioned with part A. Right, but do not evaluate an expression involving 1 or more integrals that gives the volume of the solid. So a square. The square is base squared. All right, and then you integrate that area formula. So that's what we're trying to set up. Just like the other one, you're going to have 2 separate pieces. You have to. You don't have a choice because right here the shape splits. That's our different piecewise function. So this volume is going to be given by the first piece of the piecewise function. This volume is going to be given by this piece of the piecewise function. All right, so we set that up. Each one of these little squares, this is the base of the square, and then a square rises up. This is the base of the square, and then a square rises up. So each piece, we are integrating the area. And if we look at the whole thing goes from 0 to 2, but we can't use just one function all the way from 0 to 2. So once again, we have to split it 0 to 1 and then 1 to 2. So from 0 to 1, my base is this end to this end. This end is 2 minus x squared. This end is 0. So my base is 2 minus x squared. And because I'm supposed to be integrating an area formula, I take that base and I square it. All right, so that gives me the first portion, plus, and then I repeat that for the second piece. So now I go from 1 to 2. This base is from this end to this end, which is x minus 2 squared to 0. So x minus 2 squared, and then I take that and square it. So you could just write to the fourth, but I just want to make sure that everything's completely explicit where they're coming from. So that is our setup. It is a setup, but do not evaluate. So this is your answer that you give right here. So that's how cross sections work. You see what your shape is, you write down the area formula, and then you make that fit based on your little rectangle that you have in here going from end to end. All right, part C. Part C says just the portion from 1 to 2 is revolved around the y-axis to form a solid. All right, so I'm gonna do just a little mock-up sketch of this so I don't have to like cut out. So this 1, 1 has a point right here, and then 2. So it's kind of just like this portion of a parabola, and then it cuts right here. So they just want this portion of it, and they want you to revolve around the y-axis right here. All right, so if we know that that axis is vertical, that means that the little stripes that you draw in should be horizontal. And the reason we do that is because, especially with this orientation, people get confused as to what is the right function, what is the left function. So that's why you just focus in just on this little line. When you look at the whole thing overall, it becomes a little overwhelming. But the right function is just where the right end of this little strip is sitting. And the left function is just where the left end of this little strip is sitting. So for our volume of revolution, we start with a pi. We integrate, this shape goes from x equals 1 to x equals 2, but that's not what we're looking for. Because we flipped it all on its side, we are now going from y equals 0 to y equals 1. If you look at our graph, this point right here, the y value is 0, the y value is 1. And then our setup here, we've got the right function minus the left function, which we don't actually officially have yet. The right function, if you take this expression right here, we have to rearrange it and solve for y. All right, so we have to take y equals x minus 2 squared, and we have to solve it for y. So take the square root of both sides. This would be the square root of y equals the quantity x minus 2, and then we add the 2 to both sides. Okay, so that is our expression. That is like this line right here. And then this is just a vertical line. Okay, so my capital R goes all the way to the outside of the shape here. And then our little r is just this gap right here. So capital R, we go right minus left. The right function is given by this, square root of y plus 2, minus this end right here is the axis, which is just 0. So I'm not going to write that down. So that's capital R squared. Minus little r squared goes from here to here. So this is a vertical line. They cut you off at 1. And then this obviously is a vertical line at 0. So this is just 1 minus 0 squared. And it's all in terms of y. All right, so that is our setup. And we do actually have to find it. All right, so we're going to work all this out, get the actual antiderivatives by hand. So we're integrating from 0 to 1. This needs to be FOILed out. So when you FOIL root y times root y, you get y. Root y times 2 would be a 4 root y. 2 times 2 would be 4, and then at the end we subtract 1. So this is the expression that we're integrating, and we can integrate it by hand, just a little bit of practice. So the pi's out front. Antiderivative of y would be 1/2 y squared. Plus, now this, remember, is like y to the 1/2 power. So the power pops up to a 3/2. And then we divide by 3/2, which means multiplying by 2/3. And there was already an 8 there. So we have, I'm sorry, there was already 4 there, so we have 8/3. Plus, and then the antiderivative of 3 would be 3y. We integrate that from 0 to 1. And then we multiply the whole thing by pi. All right, so plug in that 1 first. 1/2 times 1 plus 8/3 times 1 plus 3 times 1 minus, and then when you plug in 0 and 0 and 0, that whole thing is just going to be 0. So just a little arithmetic here. We can get common denominators of 6. Okay, so this would be 3 over 6. This would be 16 over 6. This would be 18 over 6. Add these together. We get, what, 21 and then 37. A lovely 37 over 6 times pi. That would be our exact answer. Because remember, you do not have a calculator on that portion of the test.